Okay, so if you have the same version of WEC as me, then you can find this package manager there. And if you have the package manager, if you open up the package manager, you can see there's a package called Excel.
I think you have mentioned that in your video.
Yeah, here. Okay, there. So with this you can open up Excel files.
Yes.
But for now, I'm not going to open up an Excel file. So I'm going to save this data as a CSV sheet. Okay?
Yeah.
And now I'm going to open that sheet up instead of this one. Okay, so here it is. So this is your data, and over here you have your weather data as well, right?
Yeah.
Okay. Now you're trying to predict occupancy, right? This one, right?
Occupancy, yes.
Okay. And you want to use weather data to do that, right?
Yes.
Okay, so let's get rid of the other data, the other columns. Okay? And these, because you're not going to use them, at least not right now. And then I'm going to take this one. It's usually better to have the thing you're trying to predict on the right-hand side. Okay, you follow me so far?
Yes.
Okay, now also, so is this already lagged data? You said it's 3 days. You called it 3 days.
Yes.
So in other words, what you mean is that this number actually comes from 3 days before, right?
Before the occupancy.
Yeah. So,
Yeah.
or what I could say is maybe this number is for this occupancy. Something like that, right?
Yes, yeah.
Okay. All right, good. So it's already lagged, you're telling me. That's
Yes.
good. All right, now one other thing that I think would be useful is to have an occupancy lag as well to predict occupancy. So what I mean is, here, I'll make a copy of this. Ready? Copy. There. Okay? But what I'm going to do is I'm going to lag this like 1 day or 2 days or 3 days or whatever. Right now I'll just lag it like you did it. I'll lag it 3 days. But you could lag it any number of days. So what I mean by that is I'm going to drag this down 1, 2, 3 days. So now, this is actually from this day, but I'm going to use it to forecast this day.
Can you say it again?
Okay, this one is actually for this day, right?
Yes.
But I'm going to use it to forecast this day, which is 3 days later.
But I already did that.
You wouldn't do that. Why not? Why wouldn't you do that?
Why do you want to use the...
Well, what I'm saying is that I think that yesterday's occupancy can be used to predict today's occupancy.
Yesterday's occupancy occupancy
can help us to predict tomorrow's or today's occupancy. You disagree with that?
Why do you think so?
You don't agree? I think it sounds natural to me.
Yes, occupancy can predict
Can be helpful in knowing what today's occupancy is.
I don't see the logic.
You don't see the logic? It sounds completely logical to me. For example, some people book. Well, okay. For example, suppose that there's a special event going on in Philadelphia.
Okay.
Then, maybe that means that the occupancy is going to go up, right?
Yes. Yep.
And maybe the event is not just 1 day long; it might be 2 or 3 days long. So the fact that it went up today might imply that it's also going to go up tomorrow.
Okay. Yeah.
So that kind of thing I'm talking about.
Okay. Okay. Yeah.
All right.
Okay.
Okay. So what? Do you see what I did? I made a copy of it and dragged it down.
Yeah.
Okay.
Yeah.
All right. So now, to clean this up, we have to delete these rows. Or that's one way to clean it up, is to delete these rows. Like that, okay? And at the bottom, it's also going to need some cleaning up.
Yes.
Here. Like that. And I always do this just in case. Just because sometimes Excel, I don't know, makes a mess somehow. So I just delete this stuff also. Okay.
Yeah.
All right, just in case. All right, now. So now we have a data set. By the way, I renamed this occupancy L3, lag 3. Okay?
Yeah.
Okay. So now we're trying to predict this column here. And we have all these things that we're going to use to predict it, right?
Yes.
Okay. So good. All right. Now, so this one is a number, right?
Number, yeah. Numeric.
Numeric. Everything except for this is not.
Events.
Right. Okay. All right. So let's save this. And now let me try and open it up and see if Excel will open it. I'm sorry, if Weka will open it. Change this to CSV. What did we call it? 3 days?
3 days.
Here. Okay, let's see what happens. Okay, we were lucky. We didn't get any error. Okay, it opened it up. Right?
Yeah. Yes.
Okay. Oh, by the way, one more thing I'd like to do. Before I do that, let me show you one other thing you might want to do. And that is, let's look for the correlations between these variables. That's a good thing to always to check. Okay?
Correlations between these variables.
Yeah.
You mean those weather factors?
Well, I mean, really, I'm looking for the correlation between these variables and the occupancy, but let's just do it. I'll just show you what I mean. I'll show you what I'm talking about doing. Let me save this as a different file, just because I want to delete one row. I want to delete the so I'll call this correlations. And I'm going to get rid of this because I'm sorry, not that one. I'm going to get rid of this one because it's not numeric. Okay? So now I'm going to check check that by going over here to data analysis. Now, if your Excel version doesn't have this, you have to go here, here. You have to go to add-ins. You have to go to Excel add-ins here. You have to go to Go, and you have to check this and click OK. Okay, good. So now I go to here, and I go to correlation there.
Correlation. Okay.
Yeah, and then I click OK, and then I check. I put in all the data. I want all the variables that I'm looking for correlations on. So I'm checking all of them like that. And I have to say that there are labels in the first row. And then I just click OK. And this is what I get. So this is a very, very high correlation. 0.93.
Yeah, that's the correlation between temperature and fuel.
Right.
Yeah.
So that means that's usually a kind of like a problem, because that probably means that this and this are basically the same thing, although they're not really. But anyway, it basically means that this and this are the same thing.
Yeah, because of the high correlation.
Yeah. Probably it means that like this is just like a formula that includes this. So it's really the same thing. So usually in that case you don't want to include both of them. But
Okay. Yeah.
okay, and it's not always true, but it's usually true. And then we also wanted to, I just want to check this. And what was the other one? This one. This is interesting. Look. How about that one?
So it's the 30.
Okay?
Yeah.
So there is a
very high.
I wouldn't say it's very high, but there's some correlation between 3 days before occupancy and today's occupancy.
Yeah.
Okay? Okay. All right. Anyway, so that's good, and you can do this analysis, and you can mention it in your report.
Yeah.
Okay. All right. Now let's go back to WECA. And because there's such a strong correlation between this variable and this variable, I think it's better to remove one of them.
Yeah.
So I'm going to remove the dew point. Like that, okay?
Yes.
Now I'm going to save this as an ARF file, because that works better. So I'm going to call it 3days.csv.arf. Okay? It just usually works better in WECA if you save it that way. All right, are you clear so far?
Yes.
All right, now each one of these that you click on, you get some information about it here, and you get the histogram of it here.
Yeah.
So the temperature, the minimum is -13. This is probably in, I don't know if this is Fahrenheit or centigrade, but anyway.
It's centigrade.
Okay, centigrade is, and 31, yeah, it's centigrade. Okay? Is the maximum.
Yes.
The mean is 10. Okay? So if we look at the humidity, the minimum is 14 and the maximum is 100. The mean is 64, and so on. Do you understand?
Yes, yeah.
And this tells you the histogram for the humidity. So sometimes often the humidity is in this range, which is about 57. Often it's in this range, and so on. Do you understand?
Yeah.
Okay. All right, so we have that. All right, now we can go and try to classify. So, and I'm going to use percentage split, like that. So I'm going to split between the training set and the testing set. Okay?
Yeah.
Now, which classifier do you want to use? Which algorithm?
Both neutral network.
Neural network.
Neural network.
Okay. So let's go to functions and multi-layer perceptron, it's called. Okay?
Yeah.
All right. And then if you want to, you can set some options there, because we learned about what we mean by the learning rate and momentum and so on. So you can adjust those or play with them and see if you get a better performance. Also, you can adjust the training time, the number of epochs or the number of cycles that you run. But I'm not going to change anything. I'm just going to leave it the way it is. Okay?
Okay.
And then you can go and you can click Start. The only thing is here, you have to set what you want to predict. So here we want to predict occupancy, so it was already set correctly. Okay?
Yes. Yeah.
And then you click Start. And by the way, I'm recording this, and I'm going to make it available to you and to other students as well.
Yeah, that would be great.
Okay, so now, unfortunately though, we only got 13%, which is not very strong. Okay?
Yeah.
And we also remember that neural networks have a lot of nodes in them, and we get some information about the nodes in here, but I don't really know how to use this information, but it is there. Okay?
Okay.
Now, we could also try, I'd like to try linear regression.
Yeah, I found like if you use linear regression, the correlation is much higher.
Okay, good. Now, let's try it. You're right, much better. Good. Very good. Now, also, you also, when you do linear regression, you get these numbers here, right?
Yeah.
And they tell you, okay, now we forgot to do one thing, and that is going back to our data set here. It's often a good idea to normalize your data. And what I mean by that is make them all the values between 0 and 100, for example. So these are not between 0 and 100, right?
Yeah.
So what you do is you take let's look this up. Sometimes it's very simple, but sometimes my brain doesn't work. So let's look up the min, max, normalization. Okay? And what that is normalization by scaling between 0 and 1. Okay, I said let's do it between 0 and 100, but you can also do it just between 0 and 1. So here's one way to do it, but that's not the best. Let me see if there's a Wikipedia entry for this. Here. No, maybe not. All right, let's look at that one. So what it says is you take you take the value minus the minimum divided by the maximum minus the minimum. Now let me show you what that means. So like here, let's take this one. Right? You see wind direction degrees?
Yeah.
Let's say I make wind direction degrees normalized. Okay?
Yeah.
And what I mean by doing, what I'm going to do is, I'm going to take this, I'm going to do this, equals this value minus the minimum of this whole column
Sure.
Okay, I did that. And then divided by the, what is it again?
The maximum minus the
Maximum of its minimum, right. The maximum of the same column minus the minimum. What is it? I2 colon I510. Okay. Okay, so you see what do you see what I did here?
Yeah.
I followed that formula, right? And what it does is it converts this to a number between 0 and 1.
Yeah.
Now I just want to copy this down all the way down to here, but I have to be careful. I don't want these to change. I don't want that 2 to change, so I have to put a dollar sign in front of that. I don't want the 510 to change, so I have to put a dollar sign in front of that.
Yeah.
I have dollar sign here, dollar sign here, dollar sign here, and dollar sign here. And then hit enter. And then I can drag it down. Okay, do you see that?
Yes. Yeah.
So that's called normalizing it between 0 and 1. Okay?
Yeah.
So sometimes that's a good idea, and could be a good idea for regression, but actually you don't have to do it. But what I'm trying to tell you about the regression is, do you see these coefficients here?
Yes.
They're supposed to tell you how important each of these variables is.
Yeah.
So, for example, this number is pretty large, 24. But this is a little bit hard to interpret because this number comes from that non-numeric data.
Yeah.
So,
Sorry.
yeah, so it's a little hard to interpret that. So I'm not going to think about that one right now. But this tells me that cloud cover has a negative coefficient. And that's pretty interesting because it means that it has a negative impact on occupancy. If cloud cover increases, then I multiply that by negative something. That means occupancy will decrease.
Yes.
Okay, so that's good, right? That shows that we're on the right track, right?
Yeah.
Okay? And okay, all right. So anyway, we did that. So I'll let you talk about the results here, okay? Now I want to show you two more things. And that is, you can currently occupancy is a numeric variable, right?
Yes.
But if you want to have a confusion matrix, then you have to have a non-numeric output variable. Okay?
Output variable.
Yeah, the thing that you're trying to predict is called the output variable.
So it's like, yeah.
Okay?
Yeah.
So if you want to use a confusion matrix, occupancy should not be numeric, should be non-numeric. Okay?
Non-numeric.
Yeah.
Okay. Yeah.
Now, I showed you one way to do that in Excel in the video. I showed you that you can do this. Wait, let me just move this away. I showed you could do something like this. Equals if Do you remember I showed this in the video?
Yeah. Yeah.
Okay.
I do remember it.
Yeah, so it would be like this, and then I said if K2 is greater than 90, then B. And then I said if K2 is greater than 85, then C. Do you remember I did something like this?
Yeah. Yeah.
And then I said if, I'll just stop doing it here because I don't want to keep typing, but
Yeah. I will look at the video later.
okay, K2 is greater than 80,
80 is like
then
C.
D. I already used C. D, and then else E.
Okay.
And then you have to make sure you have enough parentheses. So let's see. I think I have enough now. Yeah. Okay, so this was less than 80, so it's an E, right? So if I drag this down, I get these categories, right?
Yeah.
So this is a occupancy categorical or something, right?
Yeah.
Okay, so you can do that, and then if you do that, well, okay, let's see, I'll try it. All right? So I just saved this file. Now I'm going to get rid of this because I'm not going to use this now. You follow me so far?
Yes. Yeah.
And then okay, you still following me?
Yeah. So we just clean up
Right, that's right.
the Excel.
Just because Excel might misinterpret it somehow. So, okay, now let me try this one. And I'll open this one up in Excel. No, I didn't. I opened the wrong thing. Here. Okay, now I have this one, right?
Yeah.
And this variable is A, B, C, D, right? So this is
Nominal.
nominal, right?
Yeah.
Okay, and the values are E, C, D, and B. There's no A. Okay?
Yeah.
So occupancy was never above 95, I guess. All right?
Yeah.
Yeah. Now let me delete this one because I want to try and predict the nominal one, not the numeric one. So I'm going to delete it, okay? Are you following me?
Yeah.
Okay, so now I have this one, right? Just occupancy. I'm sorry, just this one here. All right, now let's try classifying this one using multi-layer perceptron. Okay, now, wow, it's wild. Really high, look at that.
Oh, it's 86%.
Right.
Very high.
Now, here's the confusion matrix. But the problem is, it's high, but it's not really so interesting. But it is very high, but I'll explain why it's not so interesting. But first of all, here's the confusion matrix, right?
Yeah.
So we learned about confusion matrix, right?
Yeah.
So here we have classified as A, B, C, or D. And we have, oh wait, something's wrong with that. Oh yeah, sorry. We have here E, D, I'm sorry, E, C, D, B, right?
Yeah.
So A stands for E. That's kind of confusing, but this is just Wecker's report calls them A, B, C, D. But A is our E, B is our C is our D, and D is our B, right? Okay?
Yeah.
All right, so what does this 147 stand for or mean?
So it's under condition.
Okay, let me say it. It means that there were 140. Total amount of data was how much in our data set?
It's around
510.
509.
Okay, right. Okay, 509, 510, right?
Yeah.
Okay, good. So it says that out of that 509 records, 147 of them were classified as E, right?
Yeah. Yeah.
Remember, E was what? Under 80%, right? Under 80% occupancy, right?
Yeah. Yeah.
So 147 of them were classified as E, means they were predicted as E, and they actually were E, right?
The actual bully. Yeah. Yeah.
You understand? Because they're in this row, they're in the first row, that's the E row, that means they actually are E, and they're in the first column, that means they were classified or predicted to be E.
Yeah. Yeah.
Okay? So what does this 1 mean here?
So they were predicted to be C, but
Right.
they're actually E.
Right, exactly right. Okay, so you understand it, right?
Yeah.
Okay. So this 1 is wrong, right?
Yeah.
And this 9 is wrong. And this 5 is wrong. And this 6 is wrong. But this 147 is correct, right?
146, but 147. Right?
Yeah, that's correct, right?
Yeah. Yeah. Yeah.
Okay. So we got a very good result here, but still it's not very interesting because what it did was it just made almost, well, put it this way, almost all of our records actually were E. If you go back here, there's a lot of E's here.
Yeah, but because I think that your
Yeah, because I didn't keep typing. I stopped at E.
yeah
Right?
If you keep typing, then probably you'll get a better result.
Well, I don't know if the percentage will be so good anymore, but it'll be maybe more interesting. But anyway, okay, but most of them were E. So, and what the algorithm is doing is it's basically just classifying everything as E almost. Not everything, but almost everything as E. So it's kind of stupid. I mean, it's probably not so useful. But the number does turn out to be very high. But I just want to caution you against getting very excited about it, because basically it's just saying, well, almost all of the occupants are actually E, and I'm just going to classify almost everything as E. The only ones that it didn't classify as E are this one, this one, this one, and this one. So how many is that? 1 plus 9 is 10, plus 2 is 12, plus 3 is 15. So it only predicted that 15 out of 500 and whatever were not E. Or something like that. That doesn't sound right, actually. Something's wrong there.
No.
That's not right. That's not right. Sorry, that's wrong. What's wrong? Oh, sorry. Wrong. Remember, we split it. 66% were testing. 66% were training, and 33% were testing, right?
Yeah.
So this is only on the 33%.
33%.
Yeah.
30. Okay.
Right? Because we did this. Here.
Yeah.
Okay, so we're only talking about where we're testing it. So it's only 33% of our entire 500 records. So that's only about, what, a third of, it's about 170 or something like that, right?
Yeah.
So most of them were in the category E. The only ones that were, okay, do you understand what I'm saying?
Yeah.
Okay. So that's why I'm saying it's not so great. Now, all right. Now we did it that way. Now I want to show you one more idea. Let me go back to the other data set, not the one that has the categorical variable in it. So that was this one. Okay?
Yeah.
Now we have occupancy is numeric.
Yeah, that one's numeric. Yeah.
Okay, you following me?
Yeah.
All right, now I want to, instead of using this method to make it categorical, I'm going to use a Weka method. Okay? Yeah, Weka has a way to do it also, so I want to show you that. All right, you ready?
Yeah.
You go to filter, and you look for a filter called discretize. Discretize means make it into discrete categories, or in other words, make it into nominal data.
Okay.
All right, discretize. So it is located here. Okay?
Okay.
It's here. You see it?
Yeah.
Okay. Now, I did this yesterday with another student, and I kept making one mistake with this this filter called discretize, and that was the only variable I want to discretize or make nominal is the last one, the occupancy variable. Okay.
Yeah.
So what I did was first you click on here, and you can set the options. Okay? You click on here, you can set the options. And this says you're going to discretize all of them from the first to the last. But I don't want to do that. I only want to discretize the last one, right?
Yeah.
So the last one is 11. So I can put in 11 there, or I can just leave the word last, but I'll just change it to 11. Okay?
Okay.
And then this says how many categories do you want to break it into. So you want to break it into, I had it just A, B, C, D, E. I had it in 5 categories, but I'm going to leave it at 10 categories. Okay, you can play around with it, okay?
Okay. Yeah.
Now I did it this way and it kept not working. Look, I'll show you. I'll do it now. Ready? The way you run this is you just go over here and you click apply. Okay, but it's not going to work. Watch. I did it. Now I click on occupancy and it's still numeric. It didn't work. Okay?
Yeah.
Because I didn't read it carefully. If you go to here and you click more, it says skips the class attribute if set. So the class attribute here means the thing you're trying to predict. It's going to skip that one. So it's going to do all of them that you indicate except for it won't do the class one. But that's exactly the one I want to change. I want to change the class attribute. The thing I'm trying to predict is called the class attribute. I want to change that one, right?
Yes. Yeah.
So I have to go here. I kept forgetting to do it. You have to go here and say no class.
No class.
Okay, so now the class is not set. So now it will work. Okay?
No class. So if you choose no class.
Because otherwise, it was like this. Before, it was this. I was saying the class is occupancy. But I don't want, if I do that, then it's not going to change it.
Okay. Yeah.
So I have to go to here. Sorry. And now it will work. Ready?
Yeah, ready.
Okay, there.
The result.
Now it made it into what?
And categories.
Yeah, nominal here, right? You see it says nominal?
Yeah.
Okay. So now it's done, and there are 10 categories. Okay?
Yeah.
So now I did basically the same thing I was trying to do with the if-then statements in Excel, but I did it in Weka.
I think it's much better to do in Weka.
Yeah, much easier, right? Okay. So now we can do the same thing again. We can try the multi-layer perceptron, and we can see how it works again. Now, when we do it, last time we only had how many categories?
Last time it was 4.
Right. We didn't have the A one, so there were only 4, right?
Yeah.
Okay, now this time there's going to be how many categories?
10.
10, right? So it's going to be a much bigger confusion matrix, right? It's going to be 10 by 10, right?
Yeah.
Okay. Here's the confusion matrix. Okay?
Yeah.
Let's check. Ah, look at that.
Nice. Yeah, it's quite bad.
Very bad. All right?
Yeah.
But anyway, that's what we got. Now we can try some other ones. For example, we could try a tree, like this one.
J48.
Yep. 20%.
Yeah.
Not so great. Okay?
Yeah. But
And also, by the way, if you use a tree, you can visualize it. You can visualize the tree. It's kind of horrible tree because it's too big.
yeah, it's very hard to see this tree.
Fit to screen. It's still too hard to see. But it starts out by checking the temperature, and if the temperature is less than 6, anyway, it does all this stuff. But there's many variables, so the tree is messy.
But I just thinking, what I can do to make the result better, like what kind of changes.
Okay, let me just say one more thing before I answer that. This is the same tree, but it's written like this. Little, you have to figure out what it means. But this is also the same tree. Okay. Now, what can you do to make it better? Okay, let me suggest one thing you can check, which we never talked about before, which is we can select, we can use Weka to select a subset of the attributes of the variables. Okay?
Yeah.
So here we can try to select attributes. Let's see what happens when we do that. So here it tells me that the only attributes that it wants to use are the temperature and the occupancy at lag 3. You see this?
Yeah.
So let's try that, and you can do that like this. I mean, you can copy the list. This is the list of variables, the first variable and the 10th one. Whoops. I'm going to copy it, and then I'm going to go back to here, and I'm going to click here. No, wrong. I'm going to, how do I do it? There's an easy way to do this. What is it? It's here. Attribute selection.
Okay.
No. Wrong. Where is it? There's an easy way to do this. I forget how to do it. Oh, it's called remove, I think. Yeah, here, remove. Click that. And you put in, these are the two that I want to keep, right?
Yeah.
And then, I'm sorry, I also want to keep 11. I don't want to remove, okay?
That's the output.
And then what you do is you click invert selection. So that means I'm going to remove all of them but these. Okay, so I click OK, and I apply it, and I get this. Okay, you see what I did?
Yes.
Now you could have just done it by hand. It would have been very simple. But if you have 100 variables, not just a few, it's easier to do this.
Yeah, definitely.
Okay, but if otherwise, I could just undo it, and I could just delete this one, 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 this one. Just delete them. Just remove them. The same. Same thing, right? Okay. All right. Now let's try and see if we get any better results, because the attribute selection is supposed to improve our forecasting ability.
Okay.
So let's see if it helps. It helped a little bit.
Yeah, 2%.
Right. Let's try.
Can you use the linear regression here?
No. You can't, because your output variable is not numeric.
Okay. Yeah.
27.
It's improving.
Yeah, it's improving. There are other attribute selection algorithms besides this one. You can choose different ones. You could test them and see if they give you better, right?
Yeah.
And search method, you have to adjust that. So you can play around with that.
So, yeah. What would you say is a good prediction here?
I don't know.
If it's about 50%?
I don't know. I don't know because I've never done it before. I'm sorry, I don't have a good answer right now anyway.
But like in the report, even though the result is not that fantastic, but I mean, I just need to write down what I did and the result of it.
Yeah.
Yeah.
And try to explain in what sense it might be useful. What I mean by that is, okay, here's an idea that I have that I've never, not really sure about, but it seems to be right to me. So here we have, oh, I'm sorry, let me try one more thing here. Suppose we made it 5 categories instead of 10. So let me undo all the steps that I did here. Okay?
Yeah.
And go back and make this only 5 categories. So I mean go back to discrete eyes and change it to 5 bins. Okay?
Yeah.
And don't forget you have to change this to,
No plus.
and you want to make sure that this says the 11th one, the last one.
Yeah.
And then go and apply it. Okay, let's. I'm just curious what will happen now. Okay, let me try it again. Oh, look at that. 37, right? And let me try this one. And that's before I didn't use attribute selection yet, right? I still have all the attributes here, right? So I didn't use the attribute selection yet. Okay, now also let me try J48. '41. Okay? Now I have a feeling, but I've never seen anybody write about this before, but it seems right to me, and I wonder if you agree or not. Here we only had 5 categories, right? In the last one we had 10 categories, right? It seems that 41% for 5 categories is not as impressive as 41% for 10 categories.
It will be much easier to like have 1.4.
Yeah, okay, so you agree with me, right?
Yeah.
But I've never seen that ever written about anywhere. But it seems to be true.
I think like statistically
It seems,
true.
yeah, it seems obviously true. But when we talk about, there's no, it's never been discussed as far as I know. I've never seen it discussed anyway. Maybe I'm wrong. But anyway, so you can talk about that as well.
Okay.
All right?
Yeah.
Okay. So I think that's enough. We've now had a video which is 53 minutes.
Yeah.
So
I think I learned a lot from.
okay. So I'm going to stop this video now.